He's back.
Welcome back.
Yeah, thanks.
Welcome back.
I had to restart my computer.
We're starting a revolution, Dre's. We're taking over the Q&A.
That's okay. That's good.
So I've done that. Okay. So let's see if I join. No, wait. We'll do this way. Nah,
Now you have 3 materials, yeah.
Yeah, it doesn't matter. It keeps them.
All right,
I
so we're
could have
back.
sworn. Yeah. I'm going to have to go, though, because I've got a text and the plumbers are like 2 minutes away.
Okay.
But, I want to learn more about it, so I'll probably check in later and probably bug you with questions. Thanks.
All right. Thank you for your talking today. Good luck with the plumbers.
Take care.
Bye.
Thanks.
See you, Sid.
See ya.
All right. So now that I'm back from the dead, remeshing was not a good idea. So let's go back to where we were, I suppose. We're doing the action editor. We had a suitcase.
Is the stream over? You
Let's-
rebooted your computer, right?
Yeah, rebooted. Is now streaming again and recording again. So I'll probably edit this later.
So Sid's question was, if you have 2 materials applied to 2 different objects and you join them, is there, I'm going to kind of phrase it my way, is there a danger of the material being applied to different faces because now it's one object and Blender has to decide how to join them?
In this case, no.
In the case of your air traffic, your tower, no. But if you had like 2 overlapping spheres, oh, there we go.
There you go. So for example, I have a sphere here and an icosphere here. The icosphere is red with a material 1. The icosphere, the sphere is a material 2, green. I put them together and hit join. You can see that material 1 is in slot A, material 2 is in slot B, and it remembers the vertex assignment of those materials. So
in the joining, are any new vertices and faces created?
Yeah.
I guess that would be where the material question would come.
All right. So now let's do another experiment. So if I have, for example, this material has 2 slots. One of them is material 1 and the other one is material 2. And I have like a couple of faces that are painted green. So let's assign this here. And vice versa as well. I'm going to have another material 1 and material 2. And I'm going to select some faces like this. And I'm going to paint it red. So if I have 2 materials like this together and then I hit join, Blender will automatically assign the correct material to the correct island. So now, if I go back into edit mode, and I select the green one, it selects all the green faces, including this one over here. If I go to the red one, and I select that, it selects all the red faces, including the one over there. So now it like reorders the slots and assigns the correct material by name together when you join them together. That's quite nice there. So it's like a smart joining.
Right. But no new faces were created, right?
Like editing, like extruding this?
Like in the intersection between the 2?
No. The joining
on the inside?
Joining is not a Boolean.
Aha.
That's the difference.
Work with Booleans?
Booleans works in the same way. So if I have these 2 objects together, and here's the cool thing. If I'm Boolean these 2 objects together and I give this a second material slot with the red material, and I Boolean this to this, and I tell it to be object, go down to bool tool, and I tell it to do a difference. If I take a look, lo and behold, it remembers that if the second object has another material slot that is identical to the object that is Booleaning, then it will assign that Boolean texture or material to the Boolean faces. So
Death Star.
the Death Star. Yeah, almost. So this gives you the power to, for example, use like an intersection material with your Boolean in real time sometimes. For example.
So, quick recap is there's never really a new face that's created in a join or a Boolean, and therefore Blender just tidily, is that even a word? In a tidy manner, just takes care of all the materials. And coincidentally, it is smart via Boolean or other kinds of joins or removals. And I think what you're also implying is that you can Boolean or by material.
Yeah, you can, for example, if this green object doesn't have the red material, and I tell it to do a Boolean with the difference, so let's go to the bool tool and make a difference. Notice that the bool is still red, right? So now let's reverse that and tell the red object to have a green material, just like the one that's going to Boolean. So it has the same material. But if we make it do the same difference Boolean, now it remembers that the bool object has the same material that this booled, or the child Boolean object, is presenting, right?
And as long as it has it on the slot, even if it's not applied, it'll transfer it over.
Exactly.
Got it.
That's
Thank you. Cool.
That's a little thing, nice and handy. Joining is really handy as well. If you want to unjoin something, you can go like this, select everything in edit mode, go to P for separate, or in underneath mesh, separate, and then do by loose parts. So anything that is not attached to anything will become a separate object. So now it's back to two objects again. So separating by loose parts is the opposite of joining. And joined meshes is usually less memory intensive than many objects. Nice little quick tip there. So I guess we could say we can think of things like with the action recorder, we can automate some of this. So for example, if I create a new sphere like this, I can go to my make a local action, create a recording. I'm going to add a material slot. I'm going to add material 1, and I'm going to stop. As you can see, the material recorder or the macro editor does not detect some things. Adding this material was not detected because I used this menu here of adding a new material. So why didn't it detect it? Let's try record that again. Select from an enumerated list. This is a list of items. And as you can see, there's no Python command. So if I do this, or I change it to like any other material, or back to 1 and then stop, it's not detecting anything. So this is the problem with the macro editor, the action recorder, is that you can only record Python commands. Some commands, like these ones with the materials, assigning material with this list here, is not a Python command. This is done in C. These are enumerated lists. And this is where Blender becomes quite complicated. So let's take a look. But there are some things that we can do to help automate, is using the Alt key. So Blender has some infamy to be object orientated and also to have active over selected. So as you can see, if I have two boxes selected, and if I hit down plus and select the other object, nothing happened, but in the first one it did. So if you hold down Alt and try to do that again, sometimes in Blender, both things will happen, but usually it does not. So how do we make it run on both objects at the same time? Let's take a look at the material slot here. Let's run it with both of them selected using the action recorder and hit play. It added it. This one has no new one and this one does. That's a problem, all right? I'm not going to save time this way. So we're going to have to start using something else. So the Alt key sometimes works, right? As an answer, the Alt key, which is basically run a Python operator on all selected, sometimes works, most of the time it doesn't. When it does work, it's super useful. So for example, here I could say underneath my item menu, I can scale. Okay, so this is just one. I'm using the one button together and I can, but if I want to, I can hold down Alt and I can move and scale both of them together. Or I can rotate both of them together. If I don't hold down Alt, I only rotate the active one, which is the lighter orange. So if I hold down Alt, it moves both of them. That's one way of doing it, but for some operations, this is not possible. So the Alt key, sometimes it works, most of the time it doesn't. So we need to use the object-based API. So this is like Python commands for the GUI, which is nice, and operators, but sometimes it doesn't work for many things. So in this case, we need to use the action recorder, and the action recorder has some limitations. It runs on one active object at a time. It cannot do some of the API. Most, yes, but not all. So sometimes it won't work for everything. So in this case, understanding the potential is it helps speed up a one versus one workflow with a chain of simple commands. Super nice. And with that, we can manage our tools for later. So for example, if I have my action recorder here, I can save this, add material slot and apply. And so for example, apply. We can also add a new action. And in this action, we can like apply scale. So I'm going to just copy the Python command, double click on this one, paste here, and just say apply scale. So you can copy your commands and apply them here. So add material slot and apply. So if I do this, boom, it adds a material slot and the scale is applied. So back to the action editor. If I want to save this for later, this is a local action. Local means it is saved inside the Blender file. But if we want it saved in all of the Blender files, we can go global to local or vice versa. We can, in the macro editor, we can select the list that we want. We can have as many as we want. We can select this command and we can make it local to global. And when we make it local to global, we can tell it to be, this is going to be an object mode operator. Hit OK. And then here in the object mode operator, we have this list thing, add material slot, apply. And we can choose the icon to whatever we want. So for example, this one, selected icon, and then hit OK. And this will change the icon of that particular operator. And now, if we select this cube like this and change the scale, and then run this operator from the global actions, boom, it is saved. And if we make a new scene with another object, and we run this and it has no material, we can run it from the global operators. Notice in the local, we've got nothing because it's a new blend file. But in the global, we can run the same action and we can go back and the scale is applied to 1 and we added a new material with one click. So that's the beauty of the action recorder, to help you save some time of running a chain of actions on one object at a time. But what happens if we don't want to do it for one object at a time? What do you think? What should we do? Do you have any ideas, Darren?
I was gonna say run a macro automated. I was just typing that I have to run to another call, and thank you for hosting. I wish I could hang out.
Yeah, that's okay though. Thanks for dropping by. Good luck with your things.
So was I right though? Before I go,
Yeah, you're right. You have to run
automate.
Yeah, basically, you have to run a loop of things on every one of the actions. So as you can see, we have a chain of operators, but in this case, if you want to run it on all of your objects, you're going to have to use the command on selected objects. So talk to you later, Darren. Thanks for this. Right, so Shawarma, Arto, I'm glad you joined us because you're a bit better at Python than me. So I have a question for you.
Yeah.
Do you know how to run a chain of operators on selected objects?
Oh, you just use a for loop and iterate through all these selected objects, and then you just do whatever operator you want to do.
Oh,
I
cool.
think.
Let's try that then.
Okay.
All right, so
No guarantee.
let's give it a go. So I'm just going to load up my notes. Give me a second. I have it saved here in my scripts. All right. So to do Blender looping, basically you need to do the first commands with all Blender scripts is this. You create a new document in the top right here, and you write in import bpy. This is the command that we use here inside the console. So we write in bpy, and this gives us all of the context, all of the data, all of the operators, and all of the properties and utilities and types and paths and everything for the application. All of the commands from the Blender API is exposed with the command bpy. With that, obviously nothing's going to happen because when we use bpy dot something, we need to do something with the objects. So for example, if I scale like this, we can take a look at this console down here. It says bpy ops, which is operator, and then transform, and then resize, and it changes the value to a certain size. So if we write this down here inside of the console, bpy.ops.transform.resize, and then we can put in a value, for example, 2, 2, and 2 inside parentheses, and then another closing parentheses. We just scaled our object up by 2. If we copy this again, it scales it up by 2 again. This is a very visual way of understanding what's happening. If we do this by -2, we can make it scale it back down again by 2 meters. Boom, whoops, it does a negative. Positive still. It's weird. Okay, so if we write this down, we can copy paste it into a script like this. And now if we run the script, it's going to do everything we want with a single click of a button by hitting run, which is nice. As you can see, it's happening. So we've got the script working correctly, but now we need to do it on both of them. If we have them selected like this, as you can see, it's working like the action editor. Hey, it did on both of them. That's weird. Ah. Arto, do you know why this happened on both? Okay, doesn't matter. Maybe we need a different operator that doesn't work on both. How about subdividing? No, I did on both. That's weird. Oh, object. Mirror both?
Is that a question or?
Yes, that is a question. Why does some operators work on both of them and not all of them?
I think operators only work on the active object. So what you'll have to do is a for loop through the selected object, and for the object in the current iteration, you set it as the active object. Then you do the operator. That's probably what you do. I don't know. Bad at Python.
Yeah, maybe it's in the edit mode. And I just insert.
Would it? No.
No? Maybe they improved it. Before I didn't used to do this. Okay. That's kind of strange. So add a material. Okay, adding the material slot. Let's run the same commands. BPYS, add material slot, and on top of that, we'll apply the scale. So we can go to the item panel, and then we can take a look. So we can see the scale. We'll just change the scale of both, and we'll just remove this. We'll look at the material, and then we'll run this. And sure enough, one of the objects has a material slot and the other one doesn't. This is applied scale, this one is. So some operators work on everything, some operators do not. For example, here in the interface of adding a material slot. So as you can see, Blender is highly inconsistent when it comes to what things will do. And this is why you need to learn how to automate things, because sometimes you might like, okay, let's apply the scale and everything's applied to all of the objects. Great, wonderful, hunky-dory, everything's lovely. But then you want to apply a material to all of your objects and it just won't. You have to do it one by one by one. So in this case, the material slot adding needs to be looped on all of the objects. This one's no longer necessary. So we're going to use the for command, right?
Yeah. Probably. Yeah, I think so.
Okay. So in this case, we're going to use this command called for. And I'm just going to just say for the objects, or for x, I guess you could say, in the BPY context of the selected objects, and then use a little double dot. We can say run this command. So if I go to, just delete all of the material slots, and then we're going to run this. You can see that I added 2 material slots to the first active object. All right. So you're going to have to use another little command here to help you work it through. Let's see if I remember this one. I think it's this one here.
Really store my code. I don't remember anything.
Yeah. So this is a bit more
That's really
complex.
complicated.
Yeah, let's see if it works though.
Need to do that?
No, still doesn't do it. God damn, which one was my code that
have a
worked?
suggestion.
Sure.
Okay, so delete whatever you added, and do the for loop. Same thing that you did.
And then instead of this,
the line after that should be bpy dot context dot view underscore layer dot objects dot active.
view layer.
View underscore layer dot objects dot active equals to obj.
Which one?
Equal to obj.
Quo?
Equal,
Quo is this?
equal,
Ah, equal, yep.
equal, obj. Should
And then
maybe
this would
it'll
be the-
work. I don't know. Yeah.
And we run. So this object and this object. Oh, there we go.
There.
Oh, that's it. That was the missing key. Alright, so let's explain this. So it's nice and simple because this is the basic bread and butter of everything that I always had trouble with. So basically, for means do a loop, alright? And in means inside this particular context. So as you can see, if we go here and click on the two objects here, and we hit bpy.context.selected objects, this will give us a list. Let's just zoom in so you can see a list of the two objects. Object bpy data objects cube and bpy data objects icosphere 01. If we add like another object and we select all three of them and we run the same command, it's going to give us three objects: cube, icosphere, and the torus. So it says for means do a loop, which the loop is going to be, and this loop will be called, I guess we could say, obj. Okay. So in means do inside that particular context. So we have a list of cube, icospheres, and torus. So it's going to run loop, loop, loop on every one of these different objects inside of it. And then we have the opening, and we use the brackets to bring it out. So thank you, Arto. You really answered this one. The holy grail was this one here. So in this case, the bpy context view layer objects active, when we use the equal signs, means set it to the current active object inside the loop. So in this case, it's going to go first loop, second loop, third loop as the active object. As you know, most of the Blender operators run only on the active object. So for example, if I hit add a new material slot, it's only going to do it on the active object. So in this case, we do a loop and we tell it every one of the objects in the loop is going to be an active object. We're going to set it as the loop, and then we're going to run the operator. And this is how you'd run a chain of operators on all of your objects. And it's kind of nice. You can do this for many different things. So for example, I made a quick little add-on to do this called my Ready Objects for Materials. And this little add-on is just basically one button, but I can click on it. And then the vertex groups, it creates 1, 2, 3, 4 vertex groups with the correct names. And it's good to go. And it works for all of the objects. Boom. And it does the same. So now all of them have the 4 vertex colors with the correct names and the correct order, ready to be used in the Painterly project. And that's how you use basically Python to start setting up some things. Obviously, there's a lot more nuances for different things. So for example, converting attributes is a command. It's a little bit more difficult, and obviously there's a lot of workarounds and none of it's consistent, but that's Blender for you. But that's the basics. So now we have the action recorder where we can apply the scale, and we can like do everything that we recorded in the macro editor, and we can copy and paste these commands into this script, and we can use these two commands here for object and bpy context selected objects and run it on everything. Super useful. And this is how we can start batch running the commands on all of the selected objects one by one instead of the other. Yes?
Drace, wonder though, could you use so you hit play to do the thing, right? In the
Correct.
action recorder. Wonder if you could copy the operator on that. Would that work?
Copy this operator?
And paste it into Python. Your script.
Of course. Let's give it a go, actually. So we'll delete this.
I'm not sure.
We're going to copy the Python command, paste it here. This is the command from AR, which is the action recorder. You're going to need the add-on to be installed first before this is registered. Make sure it's in the correct area. And select all the objects. Make sure that none of them have material slots. In this case, we should probably like do that with a script. I did it one by one by accident. So let's just make a new one, yeah? Untitled remove slots. and then hit play. 1, 2, 3. It did it. It ran the whole thing. So yeah, again, then in the material slots remove, we could say remove slots, and I'm going to use this operator, copy the Python command, paste it here, hit OK, remove slots, and if I hit this again, boom, it ran the operator on all of them. So if I select the add material again, hit run, it added the material to all of them. And if I choose the next one and hit run, then it ran all of it on all of them. So that's a nice hack around. Nice. You can also do the same with, like, for example, this one here, Smart UV Project. So index, I'm going to copy this Python command. And it's going to use the index 16 as a command. And now I can run it on all of them and hit play. And I have a problem. Maybe because it has no UVs. Nice, it does. Okay, UV groups. Oh no, this is for a specific use case. So I'll just use this. This is the slot 17. So now I can use I ran this on all of the objects, and it added a material slot to all of the objects. Let's run it again. It did the same to all of the objects. So you can use your global operators with this command as well, nice and easily. Thank you, Arthur. So as you can see, to understand the workflow, you need to create a loop, and then you need to set the active object in the loop. And then with that, you can copy and paste from the interface. If you don't see any Python commands inside the interface, you need to go to your settings, preference settings, go to your interface settings, and turn on Python tooltips, which is very handy, and turn on developer extras. Developer extras gives you the ability to right click on anything and copy the Python command. And you can also, with the action editor, you can copy to action recorder as well, which will add it automatically. So all the extra work that we were doing earlier was a waste of time. But as you can see, this is the basis for automation. Save time, save clicks, save work, do more with less. Work smart, don't work hard. And last but not least, we have another system called Serpens. This is €15 or dollars that you can use. It's not an affiliate, but once we understand the API, we understand how to use loops with selected objects, and we understand the limits of active versus selected and some things with the API, we can start creating an interface. Maybe we don't need to use the action recorder in a script. Maybe we can use an actual interface we can create our own little add-on with this add-on to help us save work. For example, Steve here, he's one of my heroes. He's created a very strong set of tools, Haggis tools, which is about what, €5? £5? $5? Or more? I don't remember, but he's created a whole bunch of different tools to help do this, like moving selections to a collection, creating vertex names on all the objects, selecting your different objects, hiding by different types, different animation tools, which are actually better than the Blender's built-in ones. And a number of different other tools, which is also very handy. So you can use other people's work, or you can create your own add-ons as well. Like, for example, what I did with my Leaving Earth preparation with this one button to ready the objects for materials. And you can do this by creating an easy interface with Serpens. So if I go into my node editor, and if I've purchased the add-on, which I have here, let me just load it up 1 second. is. I just have to load the browser first, 1 second. So if I'm in Serpens here, Serpens and Gumroad, there's a very strong Discord community and also good documentation and methods to help you create add-ons. This gives you a node editor which I have showcased earlier in these Q&As a couple while back, but you can start creating a node tree to help you create your interface very quickly without needing to learn a lot of the code, because the interface code of Blender is nice, but it does have its limitations, as in you need to learn a lot of things. So if you just drag and drop some nodes, you can help create your interface very quickly with properties, with different things. You can also learn the ins and outs of how the code works, how the interface code works, and then you can use this to chain your commands together. So Serpens is the kind of like the action recorder is super easy. You can use a little bit of Python to help you loop the action recorder, or you can use it to create your own scripts with a bit more power. And you can also create your own interface as an add-on using Serpens with all of these things in mind. And that brings it to the conclusion for today. Do you guys have any more questions? Plebes is writing. Cool.
Yeah, what I wanted to ask is I have Serpens as well, and I tried a bit around with it and tried to make something, but didn't really work. And is the action recorder in Serpens working the same like this action recorder add-on?
The action recorder works in all of the editors to some degree, as long as in Python. But I'm not sure if you can call it from Serpens. Let's just see. So I'll tell you what.
Well, Serpens has this kind of action recorder node, and I tried to make some stuff, but I think I did a mistake. But I'm curious if it's working the same.
I guess so. I'll tell you what. Let's make an events program or an operator. Interface function.
Serpens lets you record actions, but only certain actions are recorded.
Yeah, it's a bit like the action recorder.
So it's pretty much, but it's quite good. But if you're doing repetitive stuff, like I remember keystrokes and stuff.
Yeah. It actually hacked the actual action recorder and add a custom button there that works with all selected objects.
That's good. Alright, so here's the basics of and the good thing about Serpens as well is it has good examples ready for you. So for example, this interface function. The interface function creates a panel, creates a function, and it creates what happens inside the function. And with that you can use which icon you want. You can define what's in the checkbox, what's in the label. You can split the data, you get in the names, the display name of the object. And in this object you can it takes a little bit of getting used to it because a lot of it has some wireless nodes, which is okay. But you can quickly create take a look at the examples, and it also comes with a really awesome tutorial. Take a look at the tutorial as well. And give it a go. I mean, it's already been an hour, so I can't give you a full-on introduction to Serpens at the moment without screwing it up, but it's kind of like the best of both worlds. You have the concept of recording just like the action recorder, and you have the ability to use Python directly as if you were working with Python as well without needing to write the code, and you can create an add-on all in one. So it helps you save time to help you save time. Right. But that's it for today. So thanks guys.
Thanks, Trace.
Thanks.
All
Thank you,
right.
Drace.
You're welcome. So I'll be here next week at 1800 UTC on Thursday. I'm not sure what the topic is, but if you have some art or some questions that you'd like to explore or have it reviewed and praised or constructively critiqued.
Sorry, it cut. It cut. I'm sorry. Can you say it again?
All right, next week, if you have some art or some critique or some questions or a topic that you'd like to explore with the rest of us next week, next Thursday at the same time, just drop it in the Q&A and critique chat and I will put it to the queue.
Okay. I'll try to finish it on time.
Awesome. I'm really looking forward to it. I have a little sneak peek, but I'll keep it a big secret.
Okay.
And Naruto says he's making the perfect shawarma. Nice. Okay, so thanks again, guys, for hanging out, and I'll see you next week.
Thank you, Dre. See ya.
See you later.